Let us look at this example. You drive a beat pickup truck along a straight line road for 8.4 kilometers at 70 kilometers per hour, at which point the truck runs out of gasoline and stops. Over the next 30 minutes, you walk another 2.0 kilometers further along the road to a gasoline station. What is your overall displacement from the beginning of your drive to your arrival at the station? Let us pause this video and try to answer this. Let us say in this problem that you move in the positive direction of an x-axis from a first position of x sub 1 is equal to 0, then to a second position, which is your gasoline station. It says in the problem that you drove for 8.4 kilometers, but when the truck runs out of gasoline, you walk 2.0 kilometers to get in the station. Therefore, our x sub 2 is 8.4 kilometers plus 2.0 kilometers, which is equal to 10.4 kilometers. We are then asked to find for your overall displacement, where we can use the equation change in x is equal to x sub 2 minus x sub 1. We substitute the values and we will get a total displacement of 10 kilometers in the positive direction of the x-axis. Say in this problem, we are asked for the time interval from the beginning of your drive to your arrival at the station. Will you try to answer it? To answer this, we already know from the problem that you walked 30 minutes or 0.5 hour time interval. Let us assign it delta t sub walk. But what we don't know in this problem is a driving time interval, which we assign delta t sub dr for driving. We use the information we have in the problem, like the displacement when you are driving is 8.4 kilometers and the average velocity is 70 kilometers per hour. From our equation, average velocity is equal to change in x over change in time, which we will both assign dr to remind us that this is for driving. We can rearrange it as delta t is equal to delta x over average velocity. We substitute the values and perform the operations. Our final answer would be 0.12 hour. So, to find for the total time interval from the beginning of your drive to your arrival at the station, we will add these two, delta t drive plus delta t walk, which is equivalent to 0.62 hours. Let us add in this problem that we wanted to find the average speed from the beginning of your drive to your arrival at the station. We ask as well to find it both numerically and graphically. Do you think you can solve it? From our previous calculations, we know already that our total displacement is 10.4 kilometers and the total time interval is 0.62 hours. So, to calculate average velocity, we will find the ratio of the displacement of 10.4 kilometer for the entire trip to the time interval of 0.62 hour for the entire trip. Substituting the values, we will get the final answer as 16.8 kilometers per hour. To find the average velocity graphically, we will plot first our computed values. You drive at 8.4 kilometers at 0.12 hour. So, our point A is here, where your truck stops. Let us label this line from 0 to this point as driving. Then, you walk into your second position at 10.4 kilometers, where you reach this at an x sub 2 of 0.62 hour. Let us also connect these 2 points here, the point where you stop and your destination, the station which you reach through walking. Then, we will connect your initial position to your final position and find the slope of this line to find our average velocity. Again, in finding the average velocity, we compute for the ratio of rise over run. which is equal to 10.4 kilometers over 0.62 hour, and finally gives us 16.8 kilometers per hour. And that is how we can compute average velocity numerically and using position time graph. Still on the problem, suppose you pump the gasoline, you pay for it, and walk back to the truck. All these for another 45 minutes. What is your average speed from the beginning of your drive to your return to the truck with the gasoline? What would be your answer to this? Remember that in the previous video, we say that the average speed is the ratio of the total distance you move to the total time interval you take to make that move. To get this, we will find first for the total distance from the beginning of your drive, which is 8.4 kilometers. Then you walk 2 kilometers and finally go back at 2 kilometers, which your total travel distance is 12.4 kilometers. Then, the total time interval we found in our computation that you were driving for 0.12 hour, then walk 0.50 hour to get to the station, and finally pump, pay, and walk back to truck, all for 0.75 hour. Our total time is then 1.37 hours. From our previous equation, S average or average speed is equal to total distance over total time. We will substitute the values. And finally, we will get 9.1 kilometers per hour. And that is our final answer. There are many other problem-solving examples at the last part of this lecture. If you have questions, do not hesitate to give me a message or start a discussion in our BBL. That is all for this lecture. I am Gilmar De Castro.